Ageless, The Naked Truth About Bioidentical Hormones by Suzanne Somers. This book was published in April 2023, and the author, Andrew Steele, is a computer biologist with a Ph.D. in physics. He works as a researcher at the Francis Crick Institute in London, where his daily work involves using computers for DNA decoding to uncover the secrets of modern biology. He initially focused on physics, using particle accelerators to analyze magnetic and semiconductor materials. However, he transitioned from physics to biology because he realized that the ultimate human suffering arises from aging and aimed to change that. In this book, the author combines recent scientific discoveries to introduce advancements in various areas of aging research. Aging, as a topic, has been present for millennia. However, it has only gained significant attention and discussion in the past few centuries. Human lifespans remained relatively unchanged for thousands of years, and only in the last 2 to 3 centuries did a noticeable increase in life expectancy occur. The average life expectancy of Europeans was only around 20 years before the Common Era, BCE. It slowly extended to 40 years around 1850 CE, with an increase of just 1 year in life expectancy every century. However, by 2020, the average life expectancy for Europeans had risen to 80.4 years, which marked a significant doubling of lifespan from 40 to 80 years, and it happened in just 170 years, with an average increase of 1 year in life expectancy every 4 years. The factors contributing to the lengthening of human lifespans in modern times are diverse and can be broadly categorized into several areas. 1. A more varied and nutritionally balanced diet. 2. The widespread availability of public health facilities. 3. An increase in hygiene and health awareness. 4. Advancements in preventative and emergency medical technologies, including vaccines. The consistent increase in human life expectancy can be attributed to the cumulative effect of numerous technological advancements. Technological innovations have improved living standards and quality of life while extending lifespans.
Looking back at the history of medicine, we find significant milestones, such as the purification of insulin in 1922, which has since saved over 10 million lives of late-stage diabetes patients. The discovery of antibiotics in 1928 allowed humans to combat infections effectively. Recent scientific news also highlights progress in regenerative medicine, such as the successful transplantation of a genetically edited pig heart into a heart failure patient, even though the patient survived for only 2 months. This achievement opens up possibilities for future regenerative medicine. It's estimated that globally, over 150,000 people die every day, with more than 100,000 of these deaths, or around 2/3, attributed to aging-related causes. In affluent countries, this proportion can be as high as 90%. While we tend to view aging and diseases separately, from a biological perspective, they are closely connected. Every additional year of life significantly increases the risk of various diseases, including cancer, heart disease, stroke, Alzheimer's disease, and diabetes. For example, an 80-year-old person faces a 60 times higher risk of death compared to a 30-year-old.
Even if you live a healthy lifestyle, aging remains the most substantial risk factor for all diseases. Aging brings about a decline in the quality of life, including cognitive decline, memory loss, and reduced muscle strength, among other effects. Traditionally, we have treated diseases as isolated issues and sought individualized medical solutions, such as medications and surgeries, to combat cancer, heart disease, infections, and other ailments. However, we have often overlooked the underlying issue of aging itself. By addressing the fundamental issue of aging, the quality of life in the later stages is ideal, underscoring the importance of aging research and its significance. Scientists have made considerable progress in this field, with findings such as the effectiveness of dietary restriction in slowing down the aging process.
A scientist named Dr. McKay experimented with hundreds of rats, dividing them into 3 groups. One group of rats could eat whatever they liked, one group had their diet restricted immediately after weaning, and the third group was allowed to overeat for 2 weeks before having their diet restricted. The results showed that the rats with abundant nutrition who could eat freely had the most extended lives, living for 927 days. However, the two groups with restricted diets had rats that lived longer, with the longest-lived rats living for 1,321 days. An increase in lifespan of 40%. So, it's clear that eating less can significantly impact lifespan. Furthermore, scientists have discovered that specific gene mutations can affect aging. A scientist named Johnson found through research on nematode DNA that a mutation in the AAK2 gene could extend lifespan. Nematodes carrying the AAK2 mutation lived an average of 150 days, 10 times longer than normal nematodes. Some of the most resilient nematodes carrying the AG mutation lived for 270 days before passing away, roughly equivalent to a human living for 500 years. Another scientist named Cynthia Kenyon also discovered a long-lived gene mutation called DAF2. These findings opened doors to studying aging using modern genetics and molecular biology techniques. Aging is no longer viewed as just a collection of deteriorating bodily conditions, but as changes in cells and molecular biology, which allows us to explore the true meaning of aging from a scientific perspective.
If we define disease as a deviation from the standard form and function of the body, then aging undoubtedly qualifies as a disease. If aging is considered a disease, it implies it can be treated or intervened. This perspective allows researchers to study the pathological and physiological mechanisms of aging, discover mechanisms that slow the aging process, and implement targeted interventions. Moreover, if we focus on the pathways of aging rather than specific diseases, we can address the occurrence and development of diseases from various seemingly unrelated sources. This approach can compress the period of disability and dementia in later life, extend healthy lifespans, and, to some extent, increase the average life expectancy. It can also reduce individual suffering, family burdens, and societal costs. Next, let's delve into the causes of aging and anti-aging practices. The book discusses that aging can be considered a disease, and its progression can be attributed to DNA damage and mutations. Some cancer treatments, which work by damaging the DNA of cancer cells, can accelerate the aging process. For example, while chemotherapy drugs are carefully designed and radiotherapy using X-rays is aimed at tumors, other body tissues inevitably receive unintended radiation exposure. Studies have shown that women treated with radiation for left-sided breast cancer, for example, have a higher risk of heart disease compared to those treated for right-sided breast cancer because the heart receives higher accidental radiation doses. This suggests that DNA damage can directly accelerate the heart's aging and may be related to various aging phenomena.
Furthermore, research in the context of cancer treatment has highlighted potential risks for the future. Successful treatment of childhood cancers has been a significant achievement, but it often comes with potential long-term risks. Scientists conducted follow-up studies on individuals who had childhood cancer and found that as adults, they faced higher risks of heart disease, hypertension, stroke, dementia, and even secondary cancers. Ultimately, their life expectancy was reduced by about 10 years. Regarding the impact of DNA on aging, you may have heard of telomeres and their role in aging. Telomeres are known to shorten with age, and their shortening is associated with aging. When telomeres are long and in a youthful state, with sufficient length, a loss of some DNA during cell division is not a problem. However, telomeres shorten as cells continue to divide, and some crucial DNA segments become at risk. For instance, a newborn's white blood cell telomeres have around 10,000 base pairs, but by the age of 30, the average telomere length decreases to about 7,500 base pairs, and by the time a person is in their 70s, the average telomere length may drop below 5,000 base pairs. Research has indicated that excessively short telomeres can increase the risk of mortality.
Apart from DNA damage and mutations, proteins can also influence the aging process in humans. Usually, the lifespan of a protein molecule is very short, lasting only a few days while it works diligently within cells. Cells are adept at recycling, breaking down aging and damaged proteins into fragments, and then recycling them to synthesize new proteins. An essential step in this process is autophagy, which means self-eating. It's a way for cells to get rid of their internal garbage. However, as we age, the functionality of these processes declines, and autophagy can become impaired. Accumulation of excessive protein waste can accelerate the aging process. Every protein has a unique and complex structure formed during protein folding. However, even a tiny error in the protein folding process can lead to proteins adopting entirely different shapes. One type of error is known as amyloidosis, and it is present in the brains of Alzheimer's disease patients. This suggests that protein folding and misfolding can play a role in developing age-related diseases. Another way that aging can affect proteins is through glycation, where sugars stick to proteins. This process is called glycation, and similar reactions can occur with oxygen, known as oxidation. The substances added to proteins through these reactions are called adducts, and their accumulation can lead to protein dysfunction, contributing to the aging process. Changes at the cellular level also play a significant role in aging. Young cells become aged as they continually divide. This is a normal process, and it serves as an effective anti-cancer mechanism. Aging cells, which are no longer capable of dividing like young cells, act as a barrier against uncontrolled cell division that can lead to cancer. They are like extinguishing sparks before they turn into a fire. When a cell begins to age and can no longer perform its functions in tissues like a young cell, it starts secreting inflammatory factors to signal the immune system to eliminate it. The immune system can handle sporadic aging cells if it is still relatively youthful. However, as we age, various factors can lead to an increasing number of aging cells forming. 1. More aging cells are generated because the number of cell divisions increases, creating more opportunities for DNA damage to accumulate and accelerating cell aging. 2. The effectiveness of the body's immune system begins to decline, making it more difficult to detect and eliminate the expanding population of aging cells. 3. Scientists have discovered that these signals emitted by aging cells can induce normal cells to become senescent, creating a harmful feedback loop. Like a snowball effect, this process increases the risk of various diseases. Stem cells are another critical aspect to consider when discussing aging. These cells can uniquely replace damaged or dying cells, ensuring the proper function of tissues and organs. However, aging becomes more evident if the body's tissues do not receive a continuous supply of new cells from stem cells. For example, without stem cells continuously generating new cells, heart and brain cells that die off cannot be replaced, leading to permanent tissue damage. The loss or reduced efficiency of stem cells can contribute to the gradual decline in health that occurs with aging. In summary, you'll find that any errors in the processes from DNA to proteins to cells and throughout the body's signaling systems can lead to aging. Knowing these reasons means that we can design targeted therapies to combat them. The first method is clear out. This approach involves targeting the side effects of aging cells' autophagy and eliminating amyloid-like proteins contributing to aging. In 2019, the first genuine anti-aging drug for humans was developed based on this principle. It improved lung function in elderly individuals with mild to moderate idiopathic pulmonary fibrosis. The second method is replace. Stem cell therapy, immune system restoration to a more youthful state, and rebalancing the microbiome by supplementing beneficial bacteria can help rejuvenate the body. The third method is repair. While replacing all DNA in the body is not feasible, targeted interventions such as telomere rejuvenation, DNA mutation repairs, and restoring signaling molecules balance can slow the aging process. The fourth method is genetic reprogramming. This approach involves modifying one's biological characteristics through genetic reprogramming, potentially altering the body's preset programs for aging, and optimizing both beneficial and detrimental aspects. While this sounds like science fiction, advancements in gene editing, such as CRISPR technology, are making genetic reprogramming more precise and accessible, even though it is still in the early stages of human experimentation. These four anti-aging methods represent the primary research approaches scientists use in aging research. For us ordinary individuals, there are indeed concrete lifestyle recommendations that can help maximize our expected lifespan. While genetics play a role, most of our lifespan is influenced by our lifestyle choices and, to some extent, luck, which is beyond our control. However, by making conscious choices in our lifestyle, we can enhance our chances of living a longer and healthier life. Here are some scientifically supported lifestyle recommendations. 1. Avoid smoking. Smoking is a significant contributor to premature aging and various health problems. Quitting smoking is one of the most important steps you can take to improve your longevity. 2. Control your diet. A balanced and nutritious diet is crucial for a longer and healthier life. Focus on consuming various fruits, vegetables, whole grains, lean proteins, and healthy fats. Limit sugar and salt intake. 3. Regular exercise. Engaging in regular physical activity is essential. It helps maintain a healthy weight, supports cardiovascular health, strengthens bones and muscles, and promotes overall well-being. 4. Adequate sleep. Aim for 7 to 8 hours of sleep each night. Sleep is essential for various biological processes, including brain detoxification and cellular repair. 5. Oral health. Good oral hygiene is linked to longevity. Gum disease and oral infections can contribute to inflammation and health issues. Regular dental checkups and proper dental care are essential. 6. Vaccination. Keeping up with recommended vaccinations can help protect you from preventable diseases with severe health consequences, especially as you age. 7. Sun protection. Protecting your skin from excessive sun exposure can prevent premature aging and reduce the risk of skin cancer. Use sunscreen, wear protective clothing, and avoid tanning beds. 8. Monitor heart rate and blood pressure. Regularly check and manage your heart rate and blood pressure. High blood pressure is a risk factor for many age-related diseases. 9. Stress management. Chronic stress can accelerate aging. Stress reduction techniques such as meditation, yoga, or mindfulness can be beneficial. 10. Positive outlook. Maintaining a positive attitude and outlook can improve mental and physical health. Cultivate resilience and focus on things that bring you joy and fulfillment. It's important to note that it is always time to adopt a healthier lifestyle. Even if you're older, making these changes can still positively impact your health and longevity. The cumulative effects of aging can be slowed down by improved lifestyle choices, such as reducing the accumulation of DNA mutations. It's crucial to follow scientific advancements in this area regarding longevity drugs. While no magic pill exists for immortality, researchers continue exploring potential interventions that extend a healthy lifespan. However, it's essential to approach such interventions cautiously and wait for rigorous scientific evidence before considering their use. Lastly, the book emphasizes that aging is not just a scientific issue but also a political and legal one. Policies and regulations should support aging research, and there should be increased funding for research on aging rather than just treating age-related diseases. In conclusion, following a healthy lifestyle, as outlined in the book, can substantially impact your chances of living a longer and healthier life, regardless of your age.